welcome to this year's Awesome Day online conference for 2023. My name is Aarti Natarajan, and I have the pleasure of being your AWS technical trainer for this session, Introduction to the Cloud. As a technical trainer for AWS, I spend most of my time working with those interested in learning about AWS services from a technical, how does this work perspective, to a hands-on, how do I use this in my operational environment, to how can I architect a solution to meet my business needs. I teach a variety of courses such as architecting on AWS, developing on AWS, and machine learning. The cloud is an ever-changing space, so it's always great to hear about new use cases and customer stories. I particularly enjoy facilitating discussions with customers that gets us thinking about building innovative architectural solutions on the cloud, turning ideas into opportunities and helping us to serve customers better. It's a pleasure today to walk you through the different foundational services as well as some new ones in this year's Awesome Day. Today, we'll be walking through some fundamental concepts and key service areas to kickstart your learning journey and help you prepare to start building on AWS. In addition to that, we'll be discussing a few innovation areas you might be interested in knowing more about. This session serves as a great introduction to the AWS cloud. So no matter if you are completely new to AWS or just looking to learn more, you are in the right place. First up on our agenda, we're going to do an introduction to AWS and dive into some of the key foundational areas: compute, storage, databases, networking, and security. In the second half of our session, we'll shift our focus to some other really cool services that enable innovation on AWS. Looking at how AWS services can help you manage the Internet of Things, machine learning, maybe stand up a blockchain, or even control and process satellite communications with AWS Ground Station. We're also going to be talking about AWS Wavelength, a relatively new service that's underpinned by 5G technology, and how we can use that to build applications that deliver ultra-low latencies to mobile devices and end users. At the end of our session today, we will talk about next steps. What you can do to get hands-on, start building, continue learning, and also maybe even get AWS certified. So let's get started with the introduction to the cloud. Firstly, what is the cloud? I like to think of it as simply someone else's computer. But what does that mean? Well, you're connected into this Awesome Day session on your computer, maybe a personal laptop, maybe a work laptop, but either way, you are the primary user of that computer. You use it, you keep it secure, you restart it when you have to install updates. Essentially, you are in control of it. But on the flip side, if you break it, you're also responsible for that. Likewise, if you think about what you have in your on-premise data center, you typically have servers, storage, networking, and databases. And you have applications and workloads running on these physical resources. The cloud doesn't operate all that differently. You're still going to have those resources and have the ability to access them, but you're just going to do it in a much more flexible manner over the internet. With the cloud, another service provider, such as AWS, takes care of those physical resources such as servers, storage, networking for you. You don't need to manage the physical side. You just get to run your favorite applications without having to deal with that underlying infrastructure. So, with the cloud computing, it changes the way we look at the infrastructure and envision, if you will, its old software that we configure to do what we needed to do with agility. You access the physical resources you need essentially as a set of programmable resources. You can easily provision a server or increase database throughput or maybe compute power, as we'll see later, with really just a few clicks. The use of IT assets as programmatic resources gives you elasticity to be able to quickly set up and tear down infrastructure in a way that isn't possible with the traditional approach. Another key benefit of cloud computing is the ability to pay as you go, letting you test and leverage the system without being fully committed. You can stop using these services at any time and you only pay for what you consume. Finally, the best part is we can deploy the infrastructure globally in minutes. Let's now talk a bit more about the advantages of using the cloud as compared to, for example, your own on-premise environment. Firstly, we have what's called trading capital expense over variable expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, having a variable expense simply means that you are going to be paying for those infrastructure resources only when you consume them. And by taking a cloud computing approach that offers the benefit of variable expense, companies can implement innovative solutions while saving on costs. What this really means is that you can now deploy a workload and start getting immediate return on investment without having already committed a large financial outlay and the associated risks that it entails. The second advantage that we have is benefiting from the massive economies of scale. By using AWS Cloud, you can achieve a lower variable cost than you could get on your own. Because the usage from hundreds of thousands of customers is aggregated in the cloud, AWS can achieve higher economies of scale, and those economies of scale translate into a lower pay-as-you-go price because AWS passes these cost savings to you. Next, you can stop guessing capacity. It is in an on-premise environment when you make a capacity decision before deploying an application. You're often going to end up either sitting on an expensive idle resource that's not being used adequately, or maybe dealing with limited capacity if you decide to set aside less resources upfront. With the cloud, you no longer have to think about what your infrastructure capacity needs to be in 3, 6, 12 months, or even years from now. By utilizing AWS Cloud, you can provision only the resources you need for any given capacity. You can add or remove resources as your requirements change, which leads us nicely to increasing speed and agility. In a cloud computing environment, new IT resources are really just a click away. It no longer takes weeks for developers to access resources they need. The resources can be made available in minutes. This allows you to respond to unexpected capacity changes. For example, your marketing campaign was more successful than you expected, or planning accordingly to expected changes. For example, your overnight load versus peak load during the day. This also enables another key benefit. Organizations and teams can spin up a proof of concept, and if it's not working out exactly as intended, they can fail fast, so as to speak, and stop using these resources right away. As a result, organizations can iterate the development process quicker, at a lower cost, and ultimately go to market sooner. We have this term in AWS, undifferentiated heavy lifting, which refers to the actions and tasks that you currently perform that don't add direct value to your business. For example, imagine your business owns a data center. Then you would have to purchase the equipment, employ administrators to manage that equipment, and ensure it runs optimally over its lifespan. Now think about this. Your competitors are likely to have similar administrative overhead. They're going to be having data centers with equipment that needs to be maintained. So how do you set yourself apart? Well, let AWS manage the physical infrastructure. Stop spending money on running and maintaining data centers. Focus on what actually matters to your business, your customers, your staff, and your product. The last benefit that we have here is the ability to go global in minutes. You can easily deploy your application in multiple regions around the world. As we will see with our infrastructure, we can achieve global scale with just a few clicks. This means that you can provide a lower latency and a better experience for your end customers or end users at a minimal cost. So if you're going to be talking about where the cloud actually is, we need to learn about the AWS global infrastructure. AWS global infrastructure is primarily made up of regions that you can think of as geographical locations. You need to deploy a workload in Australia? No worries, deploy that into the Sydney region. How about running a workload in Europe? Great, you have plenty of regions to choose from. London is just one example. There are multiple regions deployed globally. An updated list can be found on the AWS infrastructure page, infrastructure.aws. Next, we have availability zones. Availability zones, or popularly known as AZs, are a subsection of a region. An AZ is a fault-isolated domain which allows you to create high availability within your applications. Availability zones have their own power supply, network connections, and are designed to be on different floodplains and accessed via different infrastructure. This means that a single AZ failure should not impact other AZs. This gives fault tolerance to the region as a whole. A region is typically designed with 2 or more AZs to ensure high availability and fault tolerance. Each availability zone is made up of 1 or more data centers. The data center is a highly secure facility housing all of the physical infrastructure that makes up the cloud, such as compute, physical disk for storage, networking equipment, amongst other devices. For the majority of workloads, you will typically interact only with the region or availability zone. AWS infrastructure regions meet the highest levels of security, compliance, and data protection, and there are currently 31 regions worldwide. Another important infrastructure element is the edge infrastructure. Displayed on the screen are the edge locations distributed globally. We use these to bring the content closer to your customers to improve performance. They can also be used to increase security and reduce the cost. This can be achieved by redirecting the traffic to the edge locations and caching content. A key service that uses edge location is Amazon CloudFront. We use Amazon CloudFront to build a content delivery network, or CDN. Let's now take a look at a video to understand how the AWS global infrastructure works.
In an ever-changing and uncertain world, AWS has stayed consistent by building resilient, global infrastructure designed to meet your evolving needs. AWS's infrastructure and network is architected to meet the highest levels of security, compliance, and data protection. From day one, AWS knew the importance of supporting high-transaction, low-latency applications that can replicate data between geographically dispersed data centers. That's why each AWS region is built with multiple availability zones that are separated from one another by a meaningful distance, and each have their own redundant power, networking, and connectivity. AWS's expanding global infrastructure portfolio is here to meet your needs. Choose the infrastructure type you need to build highly available applications and get performance that exceeds expectations. Pick any region around the globe for your most demanding workloads. You can use CloudFront to quickly deliver your content, AWS local zones for low latency applications, AWS Wavelength to deliver powerful 5G applications on demand, and bring the cloud to your data center with AWS Outposts.
We also have additional services that operate at the edge, including AWS Outposts, local zones, and AWS Wavelength. Let's start with AWS Outposts. Outposts is a fully managed service that extends the AWS infrastructure, AWS services, APIs, and tools to virtually any data center, co-location space, or an on-premise facility, providing a consistent hybrid experience. Local zones is a new type of AWS infrastructure deployment that places AWS compute, storage, databases, and other select services closer to larger cities, industries, or IT centers where there's currently no AWS region. And finally, we're actually going to talk about this one a little bit later, AWS Wavelength, a new service that works with 5G technology. Now, if you think about what resources you have on premises, AWS has services that can map to meet the need. Thinking about security, you might already be familiar with firewalls, access control lists, and maybe even have network or security administrators within your team or your company. AWS has services that enable you to deploy similar security constructs. We have security groups and network access control lists, which we will talk about in the networking module coming up. We've also got a service called Identity and Access Management, or AWS IAM, which helps you to provide authentication and authorization to the users of different AWS services that we're going to talk about today. So you have the ability to manage that through one single service. From a networking perspective, you might be familiar with physical devices such as routers or switches or basic networking concepts such as IP addressing, traffic distribution, and flow. We have services such as Elastic Load Balancer, which gives you the ability to distribute traffic among multiple different targets, or compute service, which we'll talk about coming up. Then we've got the Virtual Private Cloud, or VPC, which is your private network in the cloud, allowing you to control how your resources are connected to each other. When it comes to service, you might be familiar with managing, deploying, patching, or operating servers on-premise or maybe in a co-location. A key AWS service to meet this need is Elastic Compute Cloud, or EC2. We'll talk more about this in the next module, but essentially, it allows you to deploy a virtual server that you can run your workload or application. Now, AWS offers a number of different storage options depending on your requirements, whether that's network attached storage and persistent disk, maybe scratch space or caches, or a file system that needs to be shared between different EC2 instances, or even a simple object storage for a wide variety of applications. AWS also has more than 15 purpose-built databases. Amazon Elastic Block Store, or we call that as EBS, it offers easy-to-use, high-performance block storage at any scale. While Amazon Elastic File System, or EFS, provides a scalable, cloud-native NTFS file system. Amazon Simple Storage Service, or S3, provides object storage that's designed to store and retrieve any amount of data from anywhere on the web, and we'll talk about this in the next module. So hopefully this helps you to apply your current knowledge to different AWS services that we'll talk about. In the coming modules, we are going to go a little bit deeper into some of the different AWS services. Let's have a look at how some of these services can be orchestrated together to build a simple example. Let's say you have a web application that sits on a server that's accessed via the internet. The web application also needs to access some external data sources. As you can see from this architecture diagram, we have different services connected together to build our architecture. In the middle, we have our compute EC2 instance, which being a virtual server, it hosts the actual web application. This application is stored on an EBS volume, which provides block storage to the EC2 instance. The EC2 instance is deployed into a VPC that provides networking access. As far as data sources go, the EC2 instance can access the data in S3, which we said before is an object storage, or DynamoDB, which is a non-relational database. External users can access this web application via Route 53, which provides DNS resolution. We'll speak more about these different services in the upcoming modules. Now keep in mind, this is a very simple example, but you can see how connecting the different services together, you can come up with a huge variety of innovative solutions depending on what your requirements are. I like to think of individual AWS services as Lego blocks, and you put these Lego blocks together to build innovative solutions to meet the customer's business needs. Now, something important to consider is that we have different deployment models and ideas for different cloud maturity levels. What if you're working for a corporate enterprise that was set up prior to the internet? it is likely that you are going to have a large physical infrastructure deployment that you've been using for years. This is what we describe as an on-premise environment. Now, you're not going to want to just turn it off on a Friday night, migrate everything into the cloud on the weekend. On Monday, just start operating in the cloud. Alternatively, what if you work for a startup, a brand new company with great revolutionizing ideas? Chances are that you're not going to have the financial capital or time or even the desire to invest in an on-premise environment, so you might be thinking of a cloud-native design. So two terms come to mind here. Cloud native, which refers to applications that have been designed and deployed completely in the cloud. Think of newer applications in your business and all in the cloud, where you have migrated all the workloads from your on-premise environment and are now ready to shut it down. AWS cloud deployment models cover all variations across that spectrum. When you think about the legacy on-premise environment that we talked about before, these need to be slowly migrated. So you operate in a hybrid model where you have the workloads and data in both your on-premise environment and your cloud environment. While newer or greenfield applications can be designed with cloud deployment in mind, making use of the higher level services and cloud native design. Ultimately, it doesn't matter where you are in your journey. Once you start moving the data into the cloud, you start making use of the services and advantages that the cloud environment provides you. Speaking of moving your data into the cloud, where does the cloud actually sit? Well, thankfully, the cloud is not some mysterious concept. Rather, it is a concrete service that has physical infrastructure deployed globally, but it's managed for you by a cloud service provider like AWS. So let's summarize what we have learned so far. We defined cloud computing as the on-demand delivery of resources such as compute, storage, databases, analytics, intelligence, and other IT resources over the internet with the pay-as-you-go pricing to provide faster innovation, economies of scale, and flexible resources. We also talked about another key benefit of cloud computing, elasticity, the ability to automatically track and adjust the compute capacity to meet fluctuating workload demands and continue to maintain the performance for applications hosted in the cloud. In AWS, the service responsible for providing this elasticity is autoscaling. Autoscaling ensures that a sufficient number of EC2 instances are available to run the application. We also talked about different deployment models available for customers with different cloud maturity levels. You may have a private cloud within your on-premise environment where the cloud infrastructure is only provisioned for the use of multiple users within the organization or business. Public cloud is what we've been discussing so far, where computing services are offered to you through a cloud service provider such as AWS over the public internet, so anybody can pay and use them. And finally, we also talked about a hybrid model where customers have workloads and data operating in both their on-premise environment and the cloud environment. Let's move on to a few common terms that you might encounter when you're discussing the cloud. Infrastructure as a service, sometimes abbreviated as IaaS, contains the basic building blocks for cloud IT and typically provides access to networking, compute, and storage. Infrastructure as a service provides you with the highest level of flexibility and management control over your IT resources and is most similar to your existing IT resources in your on premise environment. Then we have Platform as a Service, or PaaS, which provides a complete development and deployment platform in the cloud for you to deploy your applications. In this cloud computing service model, cloud vendors provide developers with all the hardware and software environment required for building and deploying their applications and services over the internet. This helps you to be more efficient as you don't have to worry about resource procurement, capacity planning, software maintenance, patching, or any of that other undifferentiated heavy lifting tasks in running your application. Then we have Software as a Service, a cloud computing service model in which the vendor delivers you a completed product that is run and managed by the service provider so that applications need not be purchased, installed, and simply run on the user system. Now, SaaS users have to typically subscribe to the provider's software and access it using the vendor's API or the web. Then we have terms that we'll talk a lot about today: serverless computing. Serverless computing is a fully managed platform for providing compute, storage, and network resources without the need for you to provision or manage underlying infrastructure. We'll talk more about serverless technologies in the coming modules. A tech term that has gained much momentum over the past decade is big data, which describes large volumes of data in structured, semi-structured, and unstructured format that can be leveraged for gleaning valuable business insights using a number of techniques such as machine learning and advanced analytics. Big data is characterized by 4 V's: the volume of the data, the variety of the data, the veracity, and the trustworthiness of the data, and velocity. So big data processing is all about turning this raw data into actionable information through the different techniques like analytics and machine learning. I hope you enjoyed the session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of the session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Thank you for attending this session. Please join us for our next session, Module 2, an introduction to compute, storage,